Hello and welcome to EviePedia. As you may have noticed, am not E. Instead, I'm Lara, and I will be guest creating this week's Tuesday Science video, and I'll probably do some more in the future. Today, you're going to be learning about the periodic table. I know that most of you have probably already learned about the periodic table in school. So what I'm going to do is give a quick refresher course, so that maybe some of you will find this interesting, even though you thought it was the most boring thing ever in 6th grade. I'll start with a brief history. The periodic table as we know it today was created by the Russian chemist and inventor Dmitry Mendeleev. Other scientists before him had discovered patterns between different elements, but he was the first one to arrange them into a table. He published his findings in 1865, but it wasn't officially recognized until 1887. This is because in order for the scientific community to appreciate something as fact, it first needs to pass some tests. Mendeleev's periodic table was accepted because it was able to correctly predict the chemical properties of two elements that had not yet been discovered at the time of the publication. The last thing I'll do today is describe the structure of the periodic table. As you can see, the periodic table is arranged in rows and columns. The rows are called periods and the columns are called groups. I'll talk about the science behind the arrangement in another video, but for today we're going to be talking about the groups. For the most part, each group on the periodic table has elements that share certain chemical characteristics. The exception to the rule is the first element, hydrogen. It's almost always placed in the first group, but it shares basically no characteristics with the other elements in the column, which are the alkali metals, which include sodium and potassium. These are all super reactive metals that, as many of you may know, react violently with water. The next column is the alkali earth metals, which include magnesium and calcium, which are also very reactive, but not quite as reactive as the alkali metals. This big group in the middle here are the transition metals, and that includes probably most of the elements you've heard of that are metals: gold, silver, iron, copper, mercury. These are the lanthanides and the actinides at the bottom. They are basically moved out, relocated to the bottom, so that the periodic table doesn't have to stretch even longer than this, and so it fits conveniently on a piece of paper. This is one place where you'll see this period. They share many characteristics. The lanthanides are all very chemically similar to each other, and I believe so are the actinides, although those have a little bit more variety. Both the lanthanides and the actinides are all metals. These metals right here, beneath the wavy line, are often called the normal metals, which I find sort of weird, but they include aluminum, tin, and lead. If you see this dark, squiggly line, all the elements touching that line, except for aluminum, are called metalloids. They share some characteristics of metals and some of nonmetals. They all make very good semiconductors, which is why silicon is used in computers. Some of the metalloids include silicon and arsenic. And then on the top of this little square over here, these are the nonmetals, which include carbon, nitrogen, and oxygen. This column here, these are the halogens. They're all super reactive. They are also very deadly. Some of them were used as poison gases in World War I to kill soldiers. And on a smaller scale, chlorine is used in pools to kill bacteria and other stuff, and in toothpaste, fluorine serves the same purpose, and so does iodine when you put it on cuts. When used in small quantities, they're not dangerous to people, but instead are dangerous to things that are dangerous to people. Finally, this column is the noble gases. These are all very non-reactive. This is useful if you want to preserve something. For example, historic documents are often stored under argon or krypton because then they don't react as quickly and decompose. They're also, I believe, used in light bulbs to stop the filament from reacting with the air. If you're interested in the periodic table and want to learn more, ask me to do another video, and I'll talk more about the chemical aspect of why the elements share those characteristics. Thanks for watching EviePedia, and we'll see you tomorrow.